Okay, so absolute value of x equals 4 means we have two answers, -4 or 4. Let's see what happens if we switch this over to greater than or equal to 4. Um, and we'll make another number line. And we're still interested in what happens in and around 4 and -4. All right. Um, so let's take a look. We want this to be true. The absolute value of x is greater than or equal to 4. So because of that equal to, same as before, -4 and 4 are solutions. So put some points there. But it has to be, we want numbers that would give us a result that's also greater than 4. So what kind of numbers would work? What else could we possibly have? Now guys, close the Chromebooks. Close the Chromebooks, please. What else could we possibly have as a solution? We want numbers also that are greater than 4. So where on the number line, if I'm here at 4, where would I find them on the number line? Yeah, everyone's pointing this way, right? How about if I'm at -4? Yeah. Because say I'm at -5, the absolute value of -5 is 5. That works. I could just keep on going. -10, that would give me 10. -1,000, that would give me 1,000. Those are all true. What does this look like that we've seen before? Or. It looks like an or. So there's one way to remember these, and I'll tell you in a bit. Let's look at what happens when we have less than or equal to. So absolute value of x is less than or equal to 4. Okay? Make another number line. -4, 0, 4. And we're still interested in -4 or 4 because it's equal to. But let's see where else solutions lie. We want less than. If I'm at 4, where would I find numbers that would work that are less than? This way. Okay, this way. If I'm at -4, where would I find numbers that would work? This way. So it's kind of both, right? It's basically everything in between. It's everything in between that would work. So this looks like something we've seen before. It looks like and. So here's how to remember this. It's, write this down, great or for greater than. So anytime we have an absolute value inequality with a greater than symbol, it's an or inequality. Anytime we have an absolute value inequality with a less than, it's an and inequality. So this is less than. Less than. Just a way to remember. So anytime it's a less than inequality with absolute values, it's an and inequality. And then for greater than, it's an or inequality. Okay, so that's the main thing to remember. They're either going to be and inequalities or inequalities, depending on if they're less than or greater than. Okay, now let's solve some. They're going to solve just like absolute value equations. So there's two methods. I'm going to show you both methods. So let's solve and graph. We're going to solve and graph. And we're going to call this method 1. So let's do a couple. Let's do number 1. Absolute value of x minus 3 is greater than 5. Okay? Go ahead and write that down. Is this going to give me an and or a or inequality? Or. Great or. Okay? So anytime it's a greater than, it's an or inequality. So one method is you break this up into two equations like we did yesterday, okay? So we're going to break this up into x minus 3 equals negative 5, okay? And then x minus 3 equals positive 5. And then we just solve them, okay? Add 3. And we get x equals negative 2, okay? And I'll put an or there to remind me. And then we'll solve the other one. Add 3. And we get x is equal to 8. Okay? And then let's make our number line. And we're interested in negative 2, 8. Now, let's go back and, sorry. There we go. Let's go back and see what happens at negative 2 and 8. Are those going to be part of our solutions? In other words, do we need open points or closed points? Open and open. Now, how is it going to look? Like this or like that? It's or. So it's got to be like this. So now if we're going to write our solution, now that we have all our facts, it's going to be x is less than negative 2, or x is greater than 8. And there's our solution. It's an or inequality. All right. Let's try an and with this. So number 2. Absolute value of x take away 4 is less than or equal to 12. Okay, let's try this. Using that method again, just break them up like you would an absolute value equation. So we got x minus 4 equals 12. And then we have x minus 4 equals, negative 12. Sorry, negative 12. Make it negative 12. I like to start with a negative first. And then x minus 4 equals 12. So make sure that's negative. It usually works to our advantage to do it that way. Okay, solve it. We get x equals negative 8. And solve this other one plus 4. Let's do x equals 16. Okay, let's make our number line. We're interested in negative 8, 16. Let's go back and check. We do want closed points this time because we have an equal to. And this is an and inequality. We want all the numbers that are going to be less than once we apply the absolute value. So that's going to be everything in between. Okay. And so that would be, I'm going to do it in the short form. Negative 8 is less than or equal to x is less than or equal to 16. Okay, so we got two solutions. An or and an and. So that's method one. Mm-hmm. No, if you flip it, remember, you could take this, break it up into two, and turn it around. I take this portion, and I turn it around. It becomes x is greater than or equal to negative 8, and x is less than or equal to 16. That way it's everything in between. This is the shorthand method of doing an and inequality. They're usually going to the less than, but once you break it apart, it makes sense. Okay, that's method one. Okay, and if it works for you, you like it, use it. Let's get into another method. We'll do two examples, method two, and then you choose which one you like best. Method two. Okay, so let's do another one. This is going to be number 3. Absolute value of x plus 5 is less than 7. Oh, I forgot to put this is an and, just to remind us. And since we're on that, is this an and or a or? Okay. So method 2 is where you actually deal with them as inequalities to solve them. Okay. So let's break it up and solve these. So the way it works is this. When it's the negative case, like negative 7, you do this. X plus 5. We're going to use an inequality. Since it's a negative inequality, we're going to flip the inequality here, okay? It's going to be greater than negative 7. That's when we apply negative 7. So this could be negative 7. It flips, okay? And then over here, for the positive number 7, it's x plus 5 less than 7. Okay? So this is the difference. Let's go ahead and solve this in both cases. Here we go. Let's get rid of 5. We get x is greater than negative 12. And now we'll solve the other one. X is less than 2. And then we just graph this type of inequality. Okay, here we go. We want all the numbers that are greater than negative 12 and less than 2. Okay, so we're looking for numbers greater than negative 12. So they're going this way. And they also have to be less than 2. That's where and comes into play. So it would be all of these answers. Okay, so here's one solution. Another way to write this is negative 12 greater than x less than x less than 2. Okay, so here we are. All right, let's do the last one, number 4. So we have absolute value of x plus 11 is greater than or equal to 13. So this is an or. Okay, so let's break this up into two inequalities. Guys, focus. X plus 11. Remember, we're going to flip this for the negative 13. And then we have an or. And then we have x plus 11. And we're going to keep it as greater than or equal to for the positive 13. Okay. And let's solve it. So we have x is less than or equal to negative 24, or let's solve the other sign. X is greater than or equal to 2. Yes. We're almost done. Like 3 more minutes. Okay, let's graph it. And we're interested at negative 24 say 0 is here, and 2. And this is telling us negative 24 and everything less than that. And this is saying 2 and everything greater than that. And here's our solution. Okay. I guess you could do an interval if you wanted to show it as an interval, but this is fine. So these are two different methods to solve absolute value inequalities. Just remember greater and less than. Okay? All right, guys. We have delta math.